Hello everyone and welcome to the Victoria Game Engine series. This is episode 3 and today we'll be handling logging and error handling. Before we do anything in this video, I do need to make a quick code edit that I need to let everyone know about. This will only affect you if you are either not using Clang and the setup we did in the original video, or if you're compiling on Linux. You just need to, and all we need to do is we just need to get rid of static from this force inline. The reason is because when I was testing later on with this setup, we were having problems with force inline not working for classes. So that was a problem on my part, and I just needed to check that in advance. I'm amazed that I didn't pick it up, so that's whatever. But there we are, we fixed it, so everything should hopefully work from now on. Now that we've got that out of the way, let's talk about logging and error handling. Logging will generally just be the case of being able to write something to a console. It's fairly rudimentary. It's something that every application will need at some point, just as a way to either have debug information or just general information about the status of the app. That being said, error handling is going to be handled slightly differently to how one would expect. The way I want some errors to work is that we'll have two sort of error scenarios. So we'll have errors that happen during some functions where it shouldn't normally happen. So if we have a function where it's like where we expect, okay, so some errors can occur due to whatever reason, we need a way to be able to say, okay, well, an error can happen here, then we need something to happen. But there'll be some functions where an error will happen where it's not meant to normally happen, and we need a way to handle that being done properly. So with all that said, I think it's just really easy to just now go and hit the code and we'll just start making some stuff happen. So the first thing that you'll need to do is you'll need to create a new folder called IO. IO just stands for input output. This is going to be everything that relies on either user input or expecting output. So that will be using the keyboard and the mouse or motion capture, whatever really you can consider input, maybe a microphone. And then we'll consider output like things like the screen and headphones and a printer, any output device you can name. All of those will also be handled by our I/O systems. Now, one of those I/O systems is logging, because logging is an output from the application. So the way we're going to create our logger file is we're just going to create logger.h, and you can also create a logger.c++, but I'll do that in a moment. The first thing to do in this file is we need our age-old if and def and define, which we'll do there, which I'm sure nobody will get bored of very quickly. So the way we're going to be handling logging on a higher level is we're going to have one class that every function references that logs our output. So whenever you need to log something, we'll make a macro for it. I'm pretty sure we'll be making a macro for some logging that maybe we need to just do a quick debug. But for the most part, all logging will have to go through one channel. Now, the problem with this is that we want to create a class to handle a bunch of the data and functions that go along with logging and error handling. But the way the classes act by default is that they are meant to be instanced rather than one single area you can reference. And therefore, we need to design our code in such a way so that we can only reference this class once and not have to constantly keep re-referencing it. We do this through something called a singleton, which you may be very familiar with if you've worked with other game engines before and you want to see how it's done on how it is now. So now what you want to do is you want to create a class called logger. And again, it's just going to be like so. Remember, make sure that you add a semicolon there because sometimes C++ is weird about that. So classes in C++ have a few common things that you'll always see in a class. You'll have these sort of three sections that you'll constantly see referenced, which is private, public, and protected. These are three different access types for members of that class. Protected being sort of you can't access it from outside, but a class that inherits from it, which we'll get into a little bit later, can access. You can also have, as I mentioned there, private, which means that you just can't access it from outside the class itself, which is useful when you have more unsafe data types that you may want users to not mess about with, or certain data that you don't want them to manually change. You only want them to have indirectly changed through the code they use so that you can keep your tracking a little bit safer. We also have public, which means that you can use the data it's given. So I don't know, if you have a list of 15 things in this one class, well, if you make it a public variable, they can always reference all the things in that list. Or if you want a function that you want every area in your code to always be able to reference, then you need to make sure that function is public. Bringing us back a little closer to what we were talking about with a singleton class, we're just going to write a couple lines of code that I have got pasted here. And this just calls to create a section of protected variables, and we just have static logger with an asterisk singleton. So what this does is the static keyword means that it can be accessed without instancing a class. This is really important for when we want to create our singletons, because this singleton variable needs to be accessed from outside the class, because we can't actually do any of our declarations within the class without making it public and ruining the whole singleton idea, basically. And again, the static keyword, as I said, that means that it can be accessed from, it doesn't have to be instanced, so I don't have to create a logger to be able to write to whatever the singleton it has is. But since it's a protected variable, it can't be accessed, and we'll get on to how we do that in a moment. The asterisk here just means that this is actually a pointer to a logger class rather than an instance of a logger class. And this is really useful because rather than having one version that we constantly go through, we can have one class that does everything for us. This is also part of passing by reference rather than by copying it over. And this is just really important to know, is we'll get into sort of pointers and their ramifications later on in the series. But again, this is a reference to a class of logger called singleton that we can access through some of our code. The next area that we need to create is a public area. We just need a bunch of public methods or public variables and functions that we need to access. And I am just going to grab all of them and copy paste them in here. I'll try to go through all of these one by one. So we start off with a static const integer, which is our max buffer length. This is just so when we're writing to a file or we're writing a string, we want to make sure that it's of a given length, that being 32,000 characters. Heaven forbid that we ever actually get over 32,000 characters. I don't think that should ever happen, but this exists as a maximum so that we know how much we need, and therefore that how much will not really need to be used later on in the application. We also have this static point reference to a logger, get singleton. This will, as you can guess, return the reference to this. And that way we can do all of some of our code here without having to create our own class to do that. Speaking of which, we have 3 functions for logging here, which may increase in the future. That depends how I do my code. We have for the first one here, log v. That just stands for logging with a VA list, which we have here. We have a message, the VA list, and whether it's an error or not. And I'm actually going to change that now to swap around. So instead of having a VA list, we will have a bool, then our message, then our VA list. This just to keep that consistency there. So here for log f, I don't know what the f stands for. I kind of just made it up, but this basically means that we have a logging function with some variadic arguments as specified by the ... here. What that means is that when we're using this message, we'll want to format anything that we add into the function past that message into the message itself. And there are ways of being able to, there is a way that I'm currently thinking of a lot later into the program of being able to not just have a message, but be able to just straight up log integers, floats, shorts, booleans, and all of that, nulls, and I'll put those into a message along with some extra arguments, but I have to do that in the future. So that's just why I'm doing that now. And then we just have a log debug v, which will take a file, function, and line, send a message, and again, some variamatic macros to import into that message. Lastly, we have, I think I said lastly here, well, I'm wrong. Lastly, we have a logger here. This is our class constructor, and we'll just create an instance of the class we are trying to create. With all of that said and done, these are just our starting functions, and I'm just going to go and create our logger.cpp file. And we are going to add some information to this. So the first bit of information we're going to need, obviously, is to include our header file, not our C++, our header file. We are also going to need some standard library includes, which I'll just paste here. So we're going to need stdio.h for our printf, sprintf, and all those functions. We're going to need stdarg for some of our argument stuff, and we're going to need string.h for a little bit of memory stuff. Don't ask me why memory is included in a string file. I don't know. So with all those done, we now are pretty much set up to write our functions. And the first thing that we actually have in this file is we have our singleton, which we will initially instance to null pointer. The reason we do it this way rather than calling it null pointer in our header file is because it's a static member, you can't actually make it have an initial value. I don't know why, but you can't. And this way, it just means that we set a singleton in some instance to equal null pointer. So the next function that we have, of course, from that list was our get singleton item, which we can just call like so. And here we're going to write our definition for this, which is literally to return the singleton. So for those of you who are probably a bit confused right now why we're doing everything in a header file, I think I explained this in our Windows video, but it's easier to explain it now. The reason that we separate our class and our functions and stuff from a header file and then do all the definitions in here is because we want to compile these, but we don't want to constantly be referencing C++ files because it's a little bit easier to include header file because it reduces the amount of, I guess, the size of your actual product because you're not trying to constantly reference things at the same time. What it also helps is that it prevents circular includes from happening. So if you have, say, a class that is dependent on logger, say our file access class, but then that file access class uses some logger functions in its definitions, but then the logger also needs in its definitions some of the file access functions, you end up with a circular dependency that can't be resolved. And we resolve this by having a header file so that the actual file definitions don't end up with a circular dependency because all of the actual uses are not what's included. So you don't end up with that dependencies. You can still use each other, relying on one another, but because they're not referenced in the header file, they're not directly included in one another and get a whole problem going on there. So the next function that we're going to write is we're going to write our log v function, which is a void type, and we describe it as log v with our arguments, which I'll just quickly grab. One thing to note really quickly that I will come up in future proofing is that we're currently just using a built-in VA list as is right here. Normally, you want to just use a VA list from stdarg, but because I didn't want to have stdarg included in the header file, I figured it would just be easier to include one right here and use the sort of the GNU-C Clang version of VA list rather than having an include in a header file, because it's really annoying when you include things in a header file because it feels horrible that you're including standard library stuff across the whole application. So the first thing you'll want to do in this function is you'll want to create the out message, so the message that we want to print to the console, and it's going to be of size max buffer length. So that's just, again, that's an array of 32,000 individual parts we want to write to. The next thing we want to do is we actually want to call memset, and we want to basically take the message, fill it with 0, so null, and it's of size max buff length. This way, it just means that we don't end up with a random character being found in the buffer and it being read incorrectly, which can happen if you don't properly zero out. And we'll get to, this is a function that we do want to handle in memory itself, but I've only put memory off till like a couple videos later, just because I figured it's easiest to just have this temporarily before we actually start doing anything properly with memory. The next thing we want to do is we actually want to call vsmprintf, which is a really wacky name. But what it does is it takes the buffer we want to write to, so our out message. It's of size max buffer length. We want to format message into it using our VA list, which is our VA list that we have here. And what this will do is it will take our variatic arguments list, format, or that's been formatted into message, and format that into out message, which we can then use. Once that's done, we pretty much have a workable message to print. So now we just want to go to call printf, call %s, which will format a string, and \n, which will get a new line character. And we just want to call out message. And again, for printf, this will just print this message to std out because it's been formatted into the message there. And that's this function done. It really doesn't do a lot, but that's mainly because we already have our VA list. This function won't normally be used by the user because most of the time a user will not have a VA list initialized, and we will often be using the other versions. This is sort of a helper function that is really useful if you already have a VA list set up somewhere else in the application, but it really isn't useful aside from that. The much more useful function is our logf, which I'm just going to copy and paste the entire thing. I just had to quickly swap is_error from the end to the start to reflect our changes earlier above. Again, that's the problem with copy pasting sometimes. So here, logf just takes an error, the message, and some variatic arguments. It creates a built-in VA list as shown here, calls VA start, which will just format every argument that's referenced beyond that point into the message. And then it will just send that message, or that's what it will do. It will save those variatic arguments into there. And we then send it off to logv with its VA list and the message sent. And then once it's done sending that message, we just call VA end to finish formatting our variatic arguments, which would already have happened because it'll have been printed to the console. So the next thing that we're going to be doing is our log debug v function, which I'm again just going to copy and paste. So here we create and zero out our buffer. We create an argument pointer. We format our extra arguments into this message, and then we end that argument pointer. Then we call logf with false set because we always assume that our debug methods are not going to be errors. We may change this out in favor of actually logging debug methods as potentially being errors in the future. But what this does is it just calls here, I actually forgot a colon there, to say, okay, this is a debug message in the file and the function and line, and then it just sends the message with an extra tab indented to appear in our std out. So the last actual function to do is our constructor, which is called by doing logger, 2 colons, and logger. It doesn't actually necessarily return a type as is, but this is how it's declared. And all we need to do is we need to set singleton, when you can spell it, which apparently I can't, to this. This is a reference to the current instance of a log class when it's created. So all of these functions here, because they're not static functions, they will be able to reference this because it's that version of a class. And therefore, again, that is another way to be able to directly reference it. And it just means that when we call the constructor at any point, it will set the singleton from null pointer to this. And that is actually all of our logging functions and stuff set up. However, we do want to use a slightly better method of doing that. And that is using macros, of course. We are going to have 3 macros that we can use for printing, basically. So we're going to have the first one be defined as print with a message and some variatic arguments. And what it's going to expand into is to get the singleton and to log f, setting it by false because by default we don't expect printing to be an error. And if someone is using it for that way, then that's probably a bad idea. And then we're going to call va args like so. And what this means is that it saves us from having to write this all the time when we want to log something, and we can just call print and include that. You can do either way, but the way I want to do it is I always want to do print because that just makes it a little easier to understand what you're doing and look a little less cluttered when you're writing out the code. The next thing you want is you want another define, and you're going to want to print debug. After all, we created a debug function. Why not have some debug commands? So, well, we're going to need the file function, which in most cases, when you write out function, it doesn't normally highlight as being the function, but this still works. And the line. And again, we're going to want the message and the va args. When you can write va args properly. So last in the list, we're going to want a print error defined. Again, this is sort of just on a thinking about a user rather than our needs, because we're going to be using our error macros in the most cases where we need to say it's an error. So there's no point using this unless you're realistically someone who's an end user of the application. But again, I won't even bother to write out the whole thing because it is, well, we've been through this before. So this is what it is. Again, it just flips false to true when it comes to printing an error. And again, we'll handle that a lot later when we actually get to our creation of a platform layer and therefore an ability to color our output in our console. And just so I know, even though there's no real point doing this, that just lets us know that's the end of the file. So in order to test that all of this should work, we can go back into our main.c++. We can include our logger header file. We can actually delete our print uint there. We can get rid of our test file. We can even go and delete these files now because we don't need the test files anymore. We have a much better way of doing it. And what we're going to do is we're just going to call print hello world to show that all of these work, and we will hit Control-Shift-B again to compile. Ah, that's a classic mistake. Right. Yeah, so now we're going to compile. Do not write just logger.h because we're in main. It can't reference it that way. We have to give the full file path. Now we can compile. And what we see is it builds just fine. We can leave the terminal. So as I said, we can run the file. And what you'll see here in our debug console is that we get a hello world. We get a file. It tells us what file it's in. It tells us it's in our Victoria engine folder, main C++, and it's in the function main line 5, and that's the number. And we get another oops. So as we can see, it's all working. Just as something to mention for anyone who downloads from the repo, make sure that when you're compiling on Windows to set that to CPP VS I will probably keep disabling that when we're building for Linux, but for some reason they're not compatible with one another. So I'll need to update that change at some point. Now, on to error handling. Error types are going to be handled in sort of two different ways. So we're going to have our error type, and this is going to be in an enum, and it's going to contain basically every expected error that can possibly happen during any like function that we will expect to return an error to return. And it can be used to debug the error. We can have it go up with a list of error messages that we can then ensure that they are the same size as our enum, and then we can just have our errors be read from the console. And we're also going to have error macros, and error macros are going to be used in such a way so that if a condition is met that it shouldn't be meeting, or if something is null, or if something is out of bounds on an array index, then it will halt whatever function is going on, return quickly, and say, okay, right, this is what happened. I'm going to flag an error. And this way it means that we have sort of two ways of handling our errors, and they are going to differ per situation. So the first error type with our enumeration is only going to happen if we are in a situation where we're not actually trying to return anything, basically. If we're trying to get a string from a function, then there is no point returning an error type because we want a string. So that's what the function's going to return. It's not going to return the error. But if we're in a function where we're dealing with data separately, well, we want it to return an error in case the function didn't handle properly and couldn't make it to the end. So those are sort of the two situations where we'll be using those types. And again, these will be used across the application. So with that said, we need to go and create a new folder. I'm going to call it error. And inside error, we are going to have error types.h. And again, the age-old if and def define will exist in this file. So as I mentioned, we're just going to have an enum called error, and it's going to contain every error type, which I will now paste in. So we start off with OK, which is our, yeah, it's all great. The function passed with no problems being flagged. We have a failed function where maybe we don't know what failed, but something functioned. Something was unavailable. The parameter was wrong. We're out of memory, if that ever happens. The item was null. A file can't found, can't access, and a maximum thing. And the error max will not actually give an error. It's just for a thing that we're going to do in a moment. And the next thing we're going to want is we are going to want a extern const char of error messages. And this is basically going to be a list of every possible error message in one list that you can take the index or the type of error it is and put that into here, and it will give you what the error type is in a readable format. And that's going to actually be held in a C++ file. And I'm just going to copy all of the data in because it's easier to go through here. So again, error messages, you have OK, failed, unavailable, invalid parameter, out of memory, item was null, file not found, file can't be accessed. And I've put a comma there for a running comma so that when we go and add more, again, this is by no means the full list. This is just the ones that I could come up with in the time I had. So all of these will stay as is for now, and we'll add more when we need to, basically. Then there's another static assertion. This is just to let us know before we compile that the number of error messages divided by the first error message is equivalent to 8, basically, or in our case here, which would be 8. And if that's not the same, then we would expect the number of error messages to be the same, which means that we haven't updated this list, or we haven't updated this list. As pretty much error types out of the way, they don't really stay around for all that long. The next file that we need though is our error, not a folder, an error macros file. And in here we are going to contain all of our, well, macros that we'll be using to shorten down some fail conditions that can happen across the application. So in our error macros file, we're gonna first off, include the error types, which is this one. And so in this file, we're going to have two main things. We're going to first off have our printing error functions, and we're also going to have the macros, as I mentioned earlier. So every macro is going to have sort of four main types. It's going to have a normal type where it just quickly returns. It's going to have a normal type with a custom message that someone or somewhere in the code we can specify what the message is. It's going to have a version with no message but a return type. So in case the function isn't a void function, we can just call to return early. And it can also have a return type with a message in case it's a non-void function and we need to say something. So that sounds like a mouthful, but really it's not all that much. The way we write them, though, is a little bit funky. So the first thing we're going to do is we're actually going to copy and paste our two current error messages. So it gives us a brief on what it does. It tells us the file, the function, the line, the message. And here we also have the index error version, which will be used to give the index and the size so that we can always be printing index error messages, which is another type that will appear quite a lot because sometimes you're dealing with an array and you need to let the whole system know. So one quick thing before we do our macros is that we need to have a quick macro that will, when we want to call, let's say, a debug error or a fatal error, we need to be able to bring up a breakpoint in the application and say, okay, something's messed up right here. We need to look at what's going on immediately. This will only this happens because we don't want to sort of just crash the application because something was slightly wrong. We only want to crash the application in case of something really serious happening that means the application can't continue. If that's something with a draw function can't be found, our window wasn't created, something like that, where an error that caused the application to no longer continue needs to be instantly mentioned and gotten rid of. So the way we do that is we have this this debug break function. So here we've got one defined for, again, Microsoft build tools, which is __ debug break. Otherwise, if we're using Clang, we can use its built-in debug trap. There's another version for GCC. So because we don't really care about using other compilers at the moment, it will just, if you're not compiling on Clang or GCC, it will just return debug break as nothing and nothing will happen. Of course, again, in the future, we can change this. And it's probably also worth doing the error macros H thing there because I've got a little confused there. Now we actually get to do, oh wait, no, we don't. So another thing we need to do is we actually need to define the function string. So the function string just means that we take __ function and we change it to this, because this doesn't normally get highlighted, so we can't autocomplete, but this one can autocomplete. You don't really need to do that, but this just makes it a little bit easier to understand when we're doing that. And the other thing that we want to do, which feels awkward to do, is forgetting to put a hash there. So what this does is it takes condition X and just returns X. All this does is it means that we can condense a condition that we would normally check in a macro so that some of its weird conditions that can happen, that sometimes do happen, is already dealt with, and then it's expanded into checking if that's true, and then it can, the application can deal with all of the errors that we will get. Speaking of which, we have some errors to deal with, and I am actually going to copy and paste them. I'm going to copy and paste a couple right into the file. These are, and I'm going to make a note of that right here, these are error macros specifically for an out of bounds index. So what I'm going to do here is I'm going to copy and paste the first couple errors here, like so. All this does is this is our error out of bounds. It just says the index given was out of bounds, and it just calls index error. Index error will just give, well, an index error of the index and the size, and it will send that out to the console. We use these backslashes here because definition macros normally expect you to write them on one line, but the backslash key allows you to write them over multiple lines. So here, the reason we have two function declarations is because when we set this just means that we don't always have to include a message. It's already set here so that we can just say, okay, the index given was out of bounds. We can still print an error, and we do the same thing there. And now we can paste the other two in. Just need to do a quick little edit to those because they were using the printing error rather than the index error for whatever reason. And now these will just, so again, as I said earlier, we have the file function line, the index, the size. It says the index given was out of bounds. We get a message. We get here, we have a return, and we have a return and a message. So all of those errors are sent as you would expect. Now, the next thing we're going to do is we are going to get the rest of our messages and paste these in. Again, these are just macros, and these probably aren't all of the ones I'm going to use, but for now, these are all the macros I'm using, and there is a lot of them. So we have the same thing for just failing a condition. So if the condition given is true, then we want to say, okay, it was true. Well, there's a problem. Log that error. And we also have the same thing for returning and a message. And we also have the same thing for null. Sometimes in the application, we'll want to check if something was a null pointer because we need to know that it wasn't meant to be null in that case. So, and that's just checking that everything there is okay. And here we do have our condition fatal. All this does is it lets us know that a condition was true and that a fatal error has occurred. And then it calls debug break and return. In reality, all we really need to do here is we just get rid of that and change this just to a condition. Because for the most part, when we are looking at a fatal condition happening, we want to quickly look through our debugging information, look through the stack and see what went wrong, rather than having the debug break happen a lot earlier in the application, or us not being able to look at things and it just returns a value. And this just means it's a more widely used function rather than having a non-return type. Now that all of this is sorted, what we can do is we can create our error macros.c++. And in error macros.c++, we're going to include the header file. And we are actually also going to include our logger, because we're going to need our logger for a few functions. And the two functions are as follows. And here they both are. So here we have our logger get singleton, and we just call to log, and it just says the file, formats that to the function and line, and just says an error occurred and the error message there, optionally if it exists. I have added a to-do for this, and I'm actually going to copy and paste that up here as well, because I do want to make it so that when we are printing our error message, we can double check that the message itself here has actually been said, or sent, so that when we call to say an error occurred, well, we know that there's already going to be an error message by default, but we don't know if there's a user message. There's no point having this if that's just going to be blank. However, that is quite literally everything that we need in this file for now. We may, again, revisit this, re-go over all of the macros, add more macros, remove some if we don't need them. But again, this was a lot of setup. And just to show that it's working for just one confirmation, we can go up to our includes. We can include core error macros, and we can just call to error. Let's say we want a fail condition message return. So we want something to fail, and we want a return message out of it. And the fail condition will be true. We want to say that we're testing, and we're going to return 0. So here we've just got an error fail condition. It'll send the message, and it'll just say, okay, we're testing, and it returns 0. And one thing I did notice really quickly was we needed to include our core-typedefs.h, because otherwise it wouldn't have this string, the str function here, that wouldn't be defined. And of course we need it for our typedefs to work. So I've just added that in there really quickly. But again, we can see that this is working by building. We can just exit that. We can run here. And what you'll see is that we get an error, and it says in file, and the file it's in, function main, line 8. You get an error saying condition true was true, returning 0, and it returns testing. And it shows that everything is working as we would expect. And that means that everything we have as our setup is now done. So thank you very much for watching this episode. I know it was probably a lot of stuff, and there was probably things that I completely glazed over that really should have spent more time looking at. Hopefully you got something from this video. I kind of just wanted to structure around focusing more on the theory side of things, but again, it was a lot of code, and it was a lot of stuff that I maybe should have explained in more detail. Again, just let me know in the comments. But thank you very much for watching. I hope to see you in our episode 4, which will be on our variable type and creating a variant type effectively. So again, I will see you guys in the next episode. Goodbye.